The last conic section we're going to learn about is called the hyperbola. And just like the ellipse, the hyperbola has two focus points. The hyperbola is broken into two branches, as you can see there in your graphs. We're going to discuss both setups. The graph on the left is the hyperbola that crosses through the x-axis, and the hyperbola on the right crosses through the y-axis. And so we're going to discuss how do you know which axis your graph is going to cross through. The center is noted at HK, and in this particular class, we're going to leave our center at the origin. So H and K will both be 0 and 0. And so that means if you go into your formula sheet, you will notice that the formula for the hyperbola gives you H and K as part of your formula. And if you wanted to rewrite those formulas without the H and the K, that would simplify your equations quite a bit. So H and K are both going to be 0 and 0. Let's go back to our notes paper. And C, the quantity that C is representing the distance from the center to a focus point. Whether you go left, right, or up and down, that's the distance C from the center to your focus. A is the distance from the center to the vertices that are on that major axis. And as I stated, we're going to keep our hyperbola centered at the origin. All right, so in the hyperbola general forms, like you saw in your formula sheet, we now have that b squared is equal to c squared minus a squared. We no longer have the stipulation that a is greater than b. So that may or may not be true. We can't use that for the hyperbola. We do know that c is bigger than a. We do know that c is bigger than a. If you look back up at your graphs, do you see where c is located? Well, the value of a in this graph on the left would be the distance from the center to that vertex point here on the x-axis. So that distance would be a, and this distance would also be a units. And if that's a units, that little line segment would be a units long. You see where the value of c is. C is all the way over to here. So that distance would be c. And now you can see pretty quickly that the value of c is bigger than the value of a. The value of b does not show up on that graph anywhere that you can see. The value of b is useful to find the equation of the asymptotes that we'll get to. All right, so as I mentioned, you can replace h and k with 0 and 0 if you'd like, which makes this first general equation x squared over a squared minus y squared over b squared equals 1. One big difference that you'll notice from the hyperbola form to the back in the ellipse form is in the hyperbola form we have a minus sign between those two fractions. And if that were a plus sign, you would have an ellipse, but since it's a minus sign, we have hyperbola. The bottom equation could have been simplified to say y squared over a squared minus x squared over b squared equals 1. And so one thing I want to point out while we are here is that whichever variable comes first, whether it's x or if it's y, the first variable in the first fraction is going to tell you which axis your hyperbola branches will cross. And so in the first general form, you see x squared comes first. And so the branches will cross the x-axis. And in the second general form, y squared is first. And so therefore your branches will cross through the y-axis. And they are always divided by a squared first. All right, and then the second fraction has the b squared on the bottom. Now let's talk about the asymptotes. Hyperbola have asymptotes. If I go back up to your general pictures up here, picture on the right, let's draw in what that asymptote would look like. The asymptote is going to be a diagonal line, and one would go this direction, and one would go that direction. They have opposite slopes, okay? So one is a positive slope. You can see that this slope is positive slope for this one, and then this one going down the other side, it would have a negative slope. All right, so you don't have to sketch in the asymptotes, although it does make it quite a bit easier to draw your branches. If you have those asymptotes and you know where your vertices lie, your distance A from the center to your vertices on the major axis, it's pretty easy then to draw in those two branches that make up your hyperbola. So I do draw in my asymptotes just to give me a guide as where my hyperbola will look. how they will look. However, the asymptotes are not part of the actual hyperbolic graph. The general forms for the asymptotes are also on your formula sheet. Since h and k will be 0 and 0 for our class, we could change the general forms to say y is equal to plus or minus b over a times x. This would be for a hyperbola that crosses through the x-axis. So we say the x-axis is the major axis. That makes a lot of sense to most of us. The book's going to call it the transverse axis. So however you'd like to think of that is up to you. And that's where the graph once again crosses the x-axis. And then the formula below is where the graph crosses the y-axis. The transverse axis is the vertical, that's the y-axis. This one is the x-axis. So if I wanted to simplify without the h and the k, it would say plus or minus a over b times x. So you see the only difference is the slope. In the equation on top, the slope is b over a. On the equation on the bottom, it's a over b. One's positive, one's negative. That gets you two separate asymptote lines. Here's an equation we are going to come up with of a hyperbola that has the focus points at negative 5, 0 and 5, 0. 1, 2, 3, 4, 5. We'll put one there. 1, 2, 3, 4, 5. We'll put one there. Now, those are focus points. We don't cross the focus points, but it does give you an idea. It tells you which axis is going to be transverse or the major. That's the one that the hyperbola will cross through. Your focus points lie on that transverse axis. That makes it the horizontal axis. So I'll use the book's terminology. It's the transverse axis, the x-axis. The value of c is the distance from the center to your focus points. That value is 5. It does have a vertex at 3, 0. 1, 2, 3, 0 is a vertex. So I would want to notice that the other vertex is at negative 3, 0, right? Because they're the same distance from the center. And that tells you the value of a. A is 3. That's the distance from the center to the vertices. All right, I have C and I have A. I'm going to go ahead and find B right away. I am going to remember that the formula that compares A, B, and C, which is given to you on your formula sheet, it is also up here right there, is B squared equals C squared minus A squared. So I'm going to copy that down and we're going to use it. All right, I need to know B because that's going to be in my formula for the hyperbola. It's also going to be useful to find what the slope is for my asymptote lines. So B squared is 16, which means B is equal to 4, all right? I have enough information now. I can write the equation of my hyperbola. So the transverse axis is x, which means x squared comes first. The value of a is 3, so 3 squared is 9. Next is a subtraction sign. Then y squared over b squared. B is 4, so b squared is 16, and that is equal to 1. Now, there's your equation of the hyperbola. We also need to know the equations of the asymptotes. So the general form for the asymptotes is y equals plus or minus, and then you can double check your formula sheet. It's b over a times x. Y equals plus or minus b over a times x. And so we found b and we found a. So this is going to be 4 divided by 3x. So 4/3 x gives you your asymptotes. One again is positive slope, one's a negative slope. So crosses through, the asymptote rather crosses through the origin. The slope is 4 over 3. That's a rise over a run, and that's a point. There's a point. I'm going to try to get as accurate as a picture as I can. You know how I can struggle with this sometimes. That's one asymptote. The other one would be back here and here. And I'm going to connect those. That's my other asymptote. And now remember that your transverse axis is the x-axis. Don't go through the focus points. Those are focus points. We don't want to hit those. We want to hit our vertices. There's one branch of my hyperbola. Here's the other branch. And you want to just sort of follow out those asymptotes that you've sketched in to make that x. I've seen some descriptions tell you that when you plot your asymptotes, you can sort of make this interior rectangle. I'll sketch in what that rectangle is going to look like. A lot of students like to just draw the rectangle rather than using slope, and then connect the opposite corners of the rectangle to make their asymptotes. And so the rectangle from the center, you would go out whatever the value of A is, which is 3, and then up and down the distance, whichever that is B, which is 4 in this case. So that gets you the corner up here and the corner on down here, and then left 3, and then left 3 and up to there. And like I said, connect opposite corners of that rectangle to construct your asymptotes. The next example is going to give you vertices at 0, -6 and 0, +6. And I didn't give us enough space to scale this by 1s, did I? So let's go up by 2s. So 0, 6 is going to go 2, 4, 6 as a vertex. And then down 2, 4, 6, there's a vertex. And this time we have the asymptote line is equal to y equals 2 over x. Y equals 2 over x is an asymptote. Therefore, y equals -2 over x is also an asymptote, in case you were wondering. Think of that as 2 over 1, -2 over 1. Now, the transverse axis is y in this case. Y is my transverse axis. So I'm going to jot down the general form for this hyperbola, y squared over a squared minus x squared over b squared equals 1, as well as the asymptote. The asymptote has a general equation y equals plus or minus a over b times x. Now the reason I did that is because I noticed that a over b is my slope coefficient, and my slope coefficient is 2, or 2 over 1. So I'm going to make a separate equation to try to figure out the values of a and b. So 2 over 1 is equal to a over b, and so now you can figure out the values of a and b, or at least a relationship between them. Let's see, so this would say if I cross multiply, I would come up with this equation that 2 times b is equal to a. All right, so do we know a or do we know b? And yes, we do know a, because we know that the vertices are at 0, 6 and 0, -6. We know that a is equal to 6, so 2 times b equals 6, right? And so b equals 3. All right, so we come up with this relationship between a and b by utilizing the slope coefficient of your asymptote. The slope coefficient is 2 over 1, and we know that the general slope coefficient is a over b, and from there we made up this proportion, 2 over 1 equals a over b, and we cross multiplied to come up with a simplified version, which is going to say that 2 times b is equal to 1 times a. And then we remembered that we know that a is equal to 6. That's the distance to a vertex. And so then we solved for b, and we got b equals 3. B does not go on your graph as part of the hyperbola. B is useful to help you construct your asymptotes. All right, so from here, we can write the equation of a hyperbola. We have y squared divided by a squared, which is going to be 36, minus x squared over b squared, which is going to be 9, is equal to 1. So that's your general form of your hyperbola. Before you can draw a decent graph, you do want to have an idea of what those asymptotes look like. So let's try that rectangle approach, and you can decide for yourselves if you like that. So the distance that we want to go up from the x-axis to construct the height of our rectangle is going to be 6 units in both directions. Remember, we scaled the y-axis by 2s. So that's going to take us up to here where that vertex is and down to there where that other vertex is. Now, the width of your rectangle is going to be corresponding to the value of b, okay? So a tells you the height, and then b tells you the width because of the relationship right there between a and b. A is rise, B is run. So A is the vertical direction, B is the horizontal direction. B is 3, so we want to go out 3 units, both sides, to construct the width of your rectangle. So you can kind of see now that there's one corner, there's the next corner, here's a corner, and here's a corner of your little rectangle that you might want to think about as you're sketching in your asymptotes. There's my rectangle. So I'm going to connect the opposite corners, and I get something that goes something like this. And down like this. And then you can sketch in the branches of your hyperbola. The vertices we plotted way back towards the beginning at 0, 6 and 0, -6. So it goes like this on the y-axis, crosses through the y-axis. And that gives you the completed graph, which takes care of the directions. Find the equation and sketch the graph. Done. Let's do one more example before we take a break. So find the center and the transverse axis, the vertices, the foci, the asymptotes, all that good stuff. We have the equation of the hyperbola. We are going to notice that the x squared comes first. Therefore, your graph crosses the x-axis. The center, that's easy. Center will be 0, 0 for us. The transverse axis is going to be the x-axis, right? Because the x comes first. The vertices, there's only two. The vertices are where your graph crosses the axis. And because we've decided the x is the transverse axis, we know that the value of a is equal to 5, whereas b is equal to 3, right? Because a squared comes first for the hyperbola. And we want to cross that on the x. So we go 5 to the right, put a point there, go 5 to the left, put a point there. Those are your vertices, so we can write those as ordered pairs. We have 5, 0. We have negative 5, 0. The foci, the foci is asked for after the vertices, and the asymptotes. All right, so let's see what we've got. We do have enough information to find our asymptotes. The asymptotes have general form y equals plus or minus b over a times x. And we just found a and b, so y equals plus or minus 3 over 5 times x. I'll write that here where I put the asymptote. I forgot y. Y equals that. And then the foci. So that relies on the value of c. And we know the relationship between a, b, and c from your formula sheet. Tells you that b squared is equal to c squared minus a squared. And we know that b squared is 9. And we know that a squared is 25. So we can find c squared, 36. Nope, 34. Sorry about that. 34. And so c is the square root of 34. Which is a little less than 6, okay? So it doesn't really matter what you want to put for the value of c, because like I said earlier, that does not go on your graph. It's going to be somewhere on the other side of those vertices, though. We want the ordered pairs. It's important to understand that that's the x-coordinate. We'll write that as negative root 34, 0, and positive root 34, 0. So the foci and the vertices are on the same axes, same axis. All right, so we want to sketch in our rectangle to guide us to drawing our asymptotes. So what do we find for the equation? 3 over 5. Okay, so the rectangle has a height. Half of the height goes up to 3, down to negative 3, up to 3, down to negative 3. That makes up your rectangle vertices. Something like this. And then connect those opposite corners. Getting kind of sloppy here. And that makes up your asymptotes. And so your parabola, not that, the hyperbola branches go through here and through